Hi physicists, in this video I'm going to be talking to you about impulse, which is sometimes called change in momentum. I'm going to talk you through a problem and then we're going to talk about the uses of this in safety features, specifically in cars. So let's start with our equation. So this bit here, change in momentum, this is sometimes called impulse, okay? So we've got an object that changes velocity, its momentum will change. If we take the change in momentum and divide it by the time, we can find the force that must have been acting on the object to change its velocity. Now, a question that I really like on this topic comes from an exam question a couple of years ago, okay? And it's about a tennis ball being hit against a wall. So, tennis ball is hit against a wall at 8 meters per second and rebounds at 6 meters per second. And the first part of this question was to find out the change in momentum. Now, what a lot of students did was they were like, so the change in momentum, so the momentum going in, so it'd be 0.5 times 8, take away 0.5 times 6, jobs are good. But no, be really careful here when we're talking about change in momentum, because the tennis ball is rebounding from the wall. So this value here for velocity, if we're 8 going to the right, that's going to be positive. 6 going to the left would be negative, because remember, we're talking about velocity when we're talking about momentum. Direction matters. Anything moving to the right has a positive velocity. Anything moving to the left is going to have a negative velocity. So my way of working out the change in momentum is going to be, I need to turn this 500 grams into kilograms. That's why we're using 0.5 times 8 gives me 4 kilogram meters per second. 0.5 times minus 6 gives me minus 3 kilogram meters per second. And then to find the change in momentum, I'm going to do 4, take away minus 3, which would give me an answer of 7 kilogram meters per second. So the impulse on this ball would be 7 kilogram meters per second. Now, if I wanted to find out the force that was then exerted on this ball to change its momentum, I would need to work out how long it was in contact with the wall for, okay? And in this question, they said that the contact time was 100 milliseconds, okay? So I'm going to use force is equal to the change in momentum, which I've worked out, divided by the contact time, which is 100 milliseconds. So to get that into seconds, I'll divide it by 1,000. So that's 0.1 seconds. So 7 divided by 0.1, which would give me an answer of 70 newtons. So the force exerted on this ball was 70 newtons. Now, we can use this equation to help us with safety features, specifically in cars. Because the force that's exerted on the person is not only proportional to the change in momentum, but is also proportional to the change in time. If we can slow someone down over a longer period, we will actually exert less force on them. Think about it if you're catching a cricket ball, okay? Cricket ball is a really hard ball, okay? If you catch it like that and hold your hand still, you are changing its momentum over a really small time. So you get a really big force on your hands, it really hurts, you shatter fingers, okay? If when you catch it, you bring the ball down, what you're doing is you're changing the momentum over a longer time. You're slowing that ball down over a longer time. So the force is going to be less. So there are two main safety features in cars that use this, okay? The first one is seat belts. Okay, so if a car suddenly stops, the seatbelt allows you to move forward a little bit before it brings you to a stop. What that does is it increases the time it takes for your momentum to change. So it reduces the force on you, okay? In cars, what we care about is reducing the force on the passengers, because that's going to reduce injuries, okay? The second thing we've got in cars is we've got what we call crumple zones. This is one of the reasons why cars have got such big bonnets on them, okay? It's because it's designed that in a crash, that crumple zone will deform, okay? Giving you a longer time to change your momentum, reducing the force on the passengers. So these are two ways in which we can apply impulse into our everyday life. Now, I really do hope you found this video useful. If you want to check out our live lessons, then check out the link in the description of this video to see about joining in with our My Ed Space live lessons, okay? Whilst you're looking at the description of this video, you could also subscribe to this channel so I can carry on making videos like this for you. And if you want any more information, you want the notes, you want practice questions, you want worked examples, check out my resources on the My Ed Space website. I'll see you soon. Take care.